Good morning or good afternoon, dear students. For today's lesson, I'm going to discuss your homework from paragraph 7.1. I will review your answers, and all the correct answers will be shown on the PowerPoint. If you have any questions about the answers, please send me a message using Teams or using Magister. I will read out the questions, most of the time shortly, and then you can check your answers. The first ones were just easy to look up in the text. The first one, how are the electromagnetic waves that are emitted by mobile phone generated? That's done by making an alternating current in the antenna. With an alternating current, you can develop a magnetic field, and that can generate electromagnetic waves. At what speed do electromagnetic waves move through a vacuum? That's a standard number. It's the speed of light, 300,000 kilometers per second. What type of radiations have longer wavelengths than visible light? Well, you can look it up in the text. That are infrared and radio waves. Those waves are longer. And what type of radiation has a wavelength between 10 nanometers and 0.01 nanometers? Those are the X-rays. And what three things can happen to radiation that falls on an object? Well, it can pass through, it can be reflected, or it can be absorbed. And for question 2, you will have some examples. Your body is transparent to some types of radiation, but not to others. Which type of electromagnetic radiation passes through your body without being stopped? Well, that's the gamma rays. Gamma rays are electromagnetic waves that have a lot of energy and can pass through objects really easy. It can be stopped by concrete, and I think it has to be at least half a meter thick. For question B, which electromagnetic waves passes through your muscles but not through your bones? Those are the X-rays, and of course you know those from the X-ray photos where you can see your bones, but not your muscles if you have something like a fracture. Which is completely blocked by your body. Well, those are different ways. It can be light or infrared or radio waves. Well, infrared can be absorbed because you can get a little bit from the heat, but radio waves and light, your body can stop those. For question 3, you have to fill in the table. It's not that hard, I think. Most of the types of radiation and the examples are pretty common. For question 4, Elsie creates a wave motion in a skipping rope by moving one end of the up and down. She has attached the other end of it to a wall. Well, the frequency is 0.5 Hertz. You see it has 2 waves per second, one top and one bottom, and that's one wave. So 2 tops and 2 bottoms means you have 2 waves per second, and that means a frequency of 0.5 Hertz. What is the wavelength? You have to measure it. The wavelength equals 2 meters, and if you want to know the speed, well, in this case I used c, but you can use v as well for lambda times f. So 0.5 times 2 equals 1 meter per second. For question 5, it was a little bit more tough. It takes a radio signal between 3 and 21 minutes to cover the distance between the planet Mars and the Earth. Explain why the time needed can vary so much. Well, if you read on question B, perhaps you already know the distance between Mars and the Earth isn't set. Because Earth and Mars are moving around the sun, the distance between those two planets isn't always the same. And that means, because the distance isn't always the same, the time it takes can be changed as well. For the next question, I see I've miscalculated a little bit because I use only 30 minutes and it's 30 minutes and 48 seconds. So if I'm correct, you get a little bit higher number because you don't multiply it by 780, but you multiply it by 828. I will change it. Let's go to the right question, and here is the correct answer. 284,400,000 kilometers. For question C, when you don't take in account the atmosphere, it's lower because there are more substances in the atmosphere, and that means that the speed of light gets lower. You can't, of course, travel faster than the speed of light. For question D, even if you correct your calculation in B for a different speed of light in the atmosphere, you will still get the same answer. And why is that? Well, because the atmosphere is only a really small part of this enormous amount of kilometers, so it doesn't really matter. Well, these are the answers for the first 5 questions, and this is your homework for today's lesson. Please look up for Magister if you want to know the homework for the next lesson and if you want to check your answers. And if you have any questions left, please send me a message.